This is a quick video introducing you to the fundamental concepts of databases. I'm Professor Barry Brown, Department of Computer Science at Sierra College. Databases are composed of three things: entities, attributes, and relationships between the entities. Let's talk about entities and attributes first. Here's a person. This person has a name, Bob. Bob has other attributes that describe him: his age, gender, email address, and phone number. The attributes that you choose to describe something depend upon the specific application. I'm sure you can think of dozens, if not hundreds, of other attributes to describe Bob. After all, Bob has a favorite restaurant, his high school sweetheart, shoe size, hair color, height, weight, favorite band, what he ate for breakfast this morning, mother, father, the amount of change in his pocket, bank account number, the number of songs on his iPod, and IM screen name. Do we need all those attributes? Well, some or all of them might be useful for certain situations, but let's keep it simple and limit them to the first ones that I mentioned. Because we can describe Bob with attributes that make Bob unique, Bob is an instance of an entity we shall call a person. The person entity, along with its attributes, can be used to describe many persons. Here's Sue, Frank, and Alice. They all share the same set of attributes, but the actual values may be different. Every entity needs an attribute that uniquely identifies each instance of that entity. We need to find an attribute of a person that allows us to identify each and every person separately. Such an attribute is called a primary key. The primary key attribute must be unique to every person must have one, and it cannot be shared amongst more than one person. Which of these attributes would make a good primary key? How about the person's name? After all, every person has a name, but we might end up storing information about more than one Bob or Alice. Since duplicates are not allowed, we shouldn't use the name as the primary key. Can we use an email address or phone number? Well, some people don't have an email address or their own phone number. Some people have more than one, and others share an email address or phone number among several people. So neither an email address nor a phone number make very good primary keys. If we can't find a suitable primary key among our existing attributes, we should make one. Can you think of something such as a number that every person has without duplicates? Sure. Most people have something like a social security number, driver's license number, or student ID number assigned to them. These numbers are unique to each person, and no two people have the same number. In the case of persons who don't have such a number, we could just make up a number and use it temporarily until a real number is given to them. Alternatively, we could simply assign our own numbers to each person. Many organizations do exactly this. In your wallet or purse right now are probably several ID numbers which have been given to you by various stores, institutions, and organizations. They are things like membership numbers, frequent buyer numbers, medical record numbers, and so forth. So let's do that for our person entity. Here I've assigned the ID number 100 to Bob, 101 to Sue, 102 to Frank, and 103 to Alice. The entity in our database is stored as a table, here represented as a grid. Across the top of the grid are the name of the entity, in this case person, and each of the attributes. Each row of the table represents a specific person. Here's Bob's information in the first row. Subsequent rows have data for Sue, Frank, and Alice. A table is how we store data for an entity. The columns of the table are the attributes. The rows, also called records, are the specific instances of that entity. In this case, each row represents an individual person. Let's expand our database to include information about the cars that our people own. We'll describe a car by its make and model, such as Ford and Escort. By adding two more attributes to each person, a person is now described by the make and model of car that they own. Bob owns a Ford Escort. Sue drives a Toyota Camry. Frank doesn't own a car. That's okay, we'll just leave those cells blank. For Alice, we have a problem. She owns two cars, a Honda Element and a Toyota Prius. We have a couple of options available to us. One, we could squeeze both cars into the existing two cells. But that's poor form. Each cell should hold only one piece of information. Second, we could create another row for Alice and put one car into each row. But we end up duplicating Alice's personal information, and we end up duplicating her primary key, a definite no-no. The third option would be to add two more columns to the table. Let's rename the first two as Make 1 and Model 1, and add two more columns, Make 2 and Model 2. For those people that own only one car, the data about the second car will be left blank. But along comes Todd. Todd likes to fix up old classic cars. He owns 4 of them. We can expand our table to include space for 2 more cars, but then we end up with a lot of empty cells, which waste space in the table. And we're left with a real problem. What if somebody comes along who owns 8 cars? Or 20? How do we store information about people and the cars they own when we don't really know in advance how many cars they could possibly have? Taking a step back, what we're really talking about here are 2 different things: people and cars. Cars are described by a set of attributes that are different from the set of attributes that describe people. Cars and people are really 2 separate entities. A person is described by their ID, name, age, gender, email address, and phone number. A car is described by its make, model, and year. There is now a relationship between people and cars. A person is said to own cars. We will say that the cardinality between person and car is 1 to many because one person owns many cars. Many in database speak means any number of, including 0. Other cardinalities are 1 to 1 and many to many. To represent this relationship in our tables, we need to add an attribute called owner ID to the car table that establishes who owns a specific car. This kind of attribute is called a foreign key because its values are the primary keys from the person table. In a foreign key, duplicates are allowed. In fact, duplicates are necessary because the same person could own several cars. Here's Bob's car. Here is Sue's car. Frank doesn't own any cars, so his ID number doesn't appear anywhere in the car table. Alice owns 2 cars. Her ID number appears twice in the car table. And Todd owns 4 cars. His ID number shows up 4 times next to each of his cars. This is a much better way to organize the data in our database, instead of using one large table. Let's review some of the terms and concepts we covered in this video. An entity is a thing that we want to represent in a database. An attribute are things that describe an entity. Each entity is represented in a database as a table. The columns of the table are the attributes, and the rows of the table are the individual instances of that entity. A primary key is needed to uniquely identify each row of a table, and a foreign key is an attribute of one entity that refers to a primary key of another entity. Finally, the cardinality of a relationship may be 1 to 1, 1 to many, or many to many.